Suppose that a stone is projected vertically upward from an elevated point A. So that means, if we have a drawing here, we have some building, and on that building we have some cannon, and that cannon is pointed straight upwards. And we'll just say that that building is very tall, so we don't care how high it goes, but we know that it's tall enough for our purposes. And this is going to be point A. And at point A, there's some rock or stone that's projected upwards. Then, this stone goes at least a distance h up. So from here, we will call this height here. So this height here, we'll call h is equal to 0. Or we'll call this delta d is equal to 0. And then this cannonball goes up and then back down. And let's say at this height here, we'll call this delta d is equal to h. And then an equal distance down, we'll call this delta d is equal to minus h. Okay, and there's some velocity at, so we'll call this point B, and this point C. So there's some velocity at point B and at point C. Notice that I didn't say that h was the absolute top of the trajectory, because it doesn't say that. It just says that when the stone reaches a distance h below A, which is point C, right, because that's delta t is equal to negative h, because it's below point A, its velocity is double of what it was at a height h above A. It says nothing about this height h above or below A being the maximum or the minimum height that the stone is able to reach. So from here, we proceed as follows. We say, okay, what is this question actually asking? It's asking us to find the greatest height obtained by the stone above A. So it's asking us to find this height, which we don't know yet. And it wants us to show that it's equal to 5h over 3. Okay. So, to proceed, we notice that at point B, the velocity at point B, so the velocity at point B squared, that's going to be equal to the initial velocity, which is, well, that's just going to be the velocity at point A squared, right? Because there's some initial velocity here. So V naught is equal to VA. And this is going to be VB squared is equal to VA squared plus 2 times A times delta D. Okay, well, we know that gravity, or the acceleration here, so A is equal to negative G, right? Because gravity here is going to point downwards. Okay, and at point B, so let me move this over. We also know that delta D at point B is equal to H. And moreover, that delta D at point C is equal to negative H. Okay, then plugging into this formula here, we see that this is equal to VA squared minus 2GH. And it's minus because we have plus 2 times negative G, because that's our acceleration, times H. And this is the delta D at point B. Okay. So that's our velocity squared at point B. What's our velocity squared at point C? Well, that's easy to calculate. It's going to be vc squared is equal to the initial velocity, which, since these 2 points lie along the same trajectory, the initial velocity is actually the same. So it's both going to be va squared. And then this is going to be plus 2 times a times delta d sub c. But here, so va squared is the same. And now, a is still negative g, so we have minus 2 times g times negative h. And it's negative because delta d at point C is negative h because it's below point A. So we have two negatives, so that really becomes va squared plus 2gh. Okay, so we have two equations here. We have this guy, and we also have this guy. And something we also know is how to relate the velocity at B and the velocity at C. The problem tells us that the velocity at point C, the velocity is double of what it was at point B, because B is height h above A. So the velocity at point C is 2 times the velocity at point B. So we can write this out. Vc is equal to 2 times Vb. And that's just because of what we're given. This is what the problem tells us. So we can rewrite these equations plugging in what we have here. So our first equation is still going to be Vb squared is equal to Va squared minus 2gh. Our other equation is going to be Vc squared, which is really equal to 2 times Vb all squared is equal to Va squared plus 2gh. But the left-hand side is really 4 times Vb squared is equal to Va squared plus 2gh. Okay, now we can combine equation 1 and equation 2 here, because we notice there's a Va up here and there's a Va down here. And we want to find what that Va is, right? Because we want the initial velocity to find how high it actually goes. So there's a Va in either one of these, and there's a Vb in either one of these. So what we do is we get rid of this Vb. So we're going to plug this whole Vb here into this Vb. So this is going to be 4 times this Vb squared, because we have 4 times Vb squared. But what is this guy? This guy is just all of this, because all of this is equal to Vb squared. This is going to be 4 times Va squared minus 2gh, and that's equal to Va squared plus 2gh. Then we can calculate what is Va squared. Well, multiplying out the 4, this is going to be 4 times Va squared minus 8gh. And that's equal to Va squared plus 2gh. Then, adding this guy over to here, subtracting this guy over to here, we get 3 Va squared is equal to 10. It's equal to 10gh. Then we find that Va squared is equal to 10 over 3 gh. Okay, so what have we found here? What we found is that the initial velocity, the velocity when this cannonball first leaves the cannon, is 10 over 3 times g times h. That's pretty great, because we can now calculate when it reaches its maximum height. And the way we do that is as follows. So I'm going to save this guy, bring him down here. So this is our initial velocity. And drawing our picture again, so I don't have to keep on going up and down, we have this cannon, and it shoots this stone, and this stone goes up, 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 and then it flattens out. It stops going up, and it comes back down, right? At some point, it slows down to a stop, and then it moves back downwards. And what we can say is, in order to find this height, so if this guy is delta d is equal to 0, we want to find this delta d. We want to find what that is, because that's how high the cannonball goes. Because remember, that's what we're after. It says, show that the greatest height obtained by the stone above point A. So again, this is point A. And when we want to find the maximum height, the peak here, the way to do that is we say, well, we have this equation. We have V final squared is equal to V initial squared plus 2 times A times delta D. Okay. Now, what happens when we're at this top peak here? The velocity goes to 0 for a brief moment. The y velocity briefly becomes 0. So here, the final velocity is actually 0 squared. But the final velocity is 0, so the left-hand side is going to be 0 squared, which is still 0. So this is going to be 0 squared is equal to v naught squared, so the initial velocity squared. But this guy is the initial velocity. We just found that. So we can just plug in the initial velocity squared, which is 10 over 3 gh. And then we add 2 times, what's the acceleration? Well, remember, gravity points down, so that's going to be 2 times negative g times delta d. And that's the delta d that we want. We don't know it yet. So this is 0 is equal to 10 over 3 times g times h minus 2g delta d. We can then add over this guy to the other side. So this becomes 2g delta d is equal to 10 over 3 times g times h. Then we see that we can cancel this g on either side, and we can divide by a 2. So if we divide by 2, that becomes 10 over 2, which is 5. So the final displacement is equal to 5 over 3 times h, which is exactly what we wanted, right? That's exactly the answer that it told us to find. So just to recap what we did, we started by saying we know that the velocity down here is 2 times the velocity up here. Okay, so we used this fact here to plug into these two velocity equations, right? We plugged this formula into this velocity equation. And then what we got was we got these two equations here, 1 and 2. And then we noticed, okay, we want to find the initial velocity. Because once we have the initial velocity, we can calculate how high does this stone go once it's projected. So I get rid of the VB squared. And as a result, we get this equation. And from there, we can calculate all the way down here to get the initial velocity squared. Once we have that, we use the same formula we were using above. The final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times the displacement. And this displacement is the height, the maximum height that this guy reaches. And once it reaches its maximum height, its velocity will briefly be 0. So we say 0 is equal to this chunk, and then once we rearrange this and we solve for delta d, we find exactly what we wanted. And with that, that's the end of this problem. Thank you.